Hi guys, it's Dr. Justin Southey here, going through a couple of tutorial questions on limits and continuity. And we're asked to find this limit if it exists. If it doesn't exist, we must show that it doesn't exist. And this is a really nice question because we've now moved on to a three-variable function. We've got the limit as x, y, z approaches 0, 0, 0 of yz over x squared plus 4y squared plus 9z squared. Okay, of course, always first thing to do, check, can you just substitute in? And in this case, no, because if you substitute 0, 0, 0, you end up with dividing by 0. So this is not a nice continuous function at that point. Let's go ahead and try and see if we can prove that the limit does not exist. To show that it doesn't exist, we just need to exhibit two paths, any two paths where the limit along those paths are different. So our first one we're going to try is we're going to approach the point along the tried and tested standard one, the x-axis. Always a good one to start. So we're going to approach along the x-axis. Now in two dimensions, so the x-axis, we don't just have y is equal to 0, we also have z is equal to 0. Okay, so when y is 0, z is 0, we are sitting somewhere on the x-axis. So now our limit becomes the limit as x 0, 0, that shows that we're on the x-axis, as that approaches 0, 0, 0 of our function. Now, wherever we have a y and a z, we just substitute a 0, so our numerator becomes 0, and our denominator becomes x squared. Why? Because there's our x squared, this y squared is 0, and the z squared is 0, so we end up with our function looking like that. And of course this is equal to the limit as x 0, 0 approaches 0, 0, 0 of 0. Why? Because we've got 0 divided by something. That something is non-zero. Why? Because x is approaching 0. It's not equal to 0. We don't care what happens at 0. We care what happens at values close to 0. So at values close to 0, x is non-zero. So 0 divided by a non-zero number is 0. Now we've got the limit of a constant, and that's simply equal to the constant. Alright, so as we approach this point along the x-axis, we get a limit of 0. Now the next thing to try is the y-axis. So put x and z equal to 0. Try the z-axis. Unfortunately, both of those will give you the same answer as this one here, so that doesn't really help. We're going to try another line, and looking at the function, it might be useful to have y and z the same, so that when we multiply them together we get a square, because we've got a whole lot of squares on the bottom, and maybe we can somehow cancel those out. In fact, we're going to approach along something where y is equal to z. Now of course that's not enough, because in 3 dimensions y is equal to z is a plane, and we need to be on a line, so we also need to somehow restrict the x value. So let's just put the x equal to 0. So putting x equal to 0 puts us in the yz plane, and then within the yz plane we're putting y is equal to z, so we're going along the 45-degree line. So this is, you just need to convince yourself that this is a line in 3-dimensional space. And now of course our limit becomes the limit x is 0, y is y, and z is also y. So that shows that we're on that line there, 0, y, y. That's approaching the point 0, 0, 0. And now our function becomes y squared, we replace z with y, all over x squared disappears because x is 0, 4y squared stays 4y squared, and 9z squared becomes 9y squared, because of course y is equal to z. We can simplify this just a little bit. The limit as 0, y approaches 0, 0, 0 of y squared over 4y squared plus 9y squared is of course 13y squared. And now you can see exactly why we chose those things, because we got y squared cancels top and bottom. Again, they can cancel. We don't have a division by 0, because we don't care what happens when y is equal to 0. We're looking at the limit as y approaches 0, so we're looking at values close to 0, but non-zero values. And a non-zero y squared divided by a non-zero y squared is simply 1. So now we've got the limit of a constant, 1 over 13, that's simply equal to the constant. So this is equal to 1 over 13. Right, so what have we achieved? Aha, well, we've got the limit along this path here is equal to 1 over 13. We've got the limit along the x-axis is equal to 0. We've shown two approaches along paths that are not equal. Therefore, we can conclude that the limit in general, the limit as x, y, z approaches 0, 0, 0, we can conclude that that does not exist. Okay, so the only tricky thing about this example was that it was a 3-variable function. Otherwise, it's exactly the same as the 2-variable case. Find 2 lines where the limits are different and show that, and therefore you can conclude that the limit does not exist.